right, everybody, buckle up, because today we're doing a deep dive on economizers.
Oh, yeah.
You sent this
That'd
in.
make it good.
You sent this in this presentation about economizers in the Anoka-Hennepin School District in Minnesota.
Yes.
And
Really interesting stuff.
yeah, let's dig in.
Really gets into whether economizers actually work or not.
Yeah.
Which is a question I think we all have.
Yeah, and I mean, we always hear about them, They're supposed to save energy
Right.
by using free cool air.
Of course.
And this presentation was led by Michael R. Lavelle. And
Yes, yeah, he's a good one.
yeah, so he really takes a look at
That was his stuff.
if that's actually true
Yeah.
and if that's always the reality.
Exactly. And it's a real world setting.
Okay.
This isn't, some theoretical
Yeah.
lab experiment. This is the Anoka-Hennepin School District.
Right.
52 schools, over 6 million square feet
Wow.
of building space.
Yeah.
And get this, around $5 million in annual energy costs.
Wow. So,
So huge opportunity for savings.
yeah, big time. Okay, so before we get into the weeds here,
Yeah.
let's make sure we're all on the same page.
Yeah.
What exactly is an economizer and
Well-
how is it supposed to work?
Yeah, so an economizer is basically an HVAC component that brings in cooler outside air to reduce the load on your mechanical cooling system,
Right.
which in turn saves you energy.
Okay.
So on those nice days when it's more comfortable outside than it is inside, the economizer kicks in, brings in that fresh air, and gives your AC a break.
So it sounds like a no-brainer.
Yeah, it sounds simple, right?
Right. But as you said, this presentation digs into what happens when things don't quite go according to plan.
Well, exactly. And one of the big issues is how economizers are controlled.
Okay.
There's a bunch of different approaches out there. Some rely on dry bulb temperature.
Okay.
Others use humidity or even enthalpy, which is both temperature and humidity, factored in.
Okay.
And, ideally, enthalpy control should be the most efficient.
Okay. Okay.
But
But there's a catch.
there's always a catch, right?
Right.
Even the smartest control systems out there are only as good as the information they're getting.
Right.
Garbage in, garbage out, right?
Right.
So in this case, Anoka-Hennepin, they found these big differences between what their sensors were reading and what was actually happening outside.
Okay. So we're talking about faulty sensor readings.
Yeah. That's a recipe for disaster right there.
Yeah. That sounds like a recipe for trouble, for sure.
For sure. And it's not always obvious when these errors are happening either.
Right.
For example, they found that the relative humidity readings were sometimes dropping to 0
Really?
and staying there for hours.
0%.
Yeah.
That's like a desert.
That's bone dry.
Yeah.
Yeah.
I'm guessing that doesn't happen very often in Minnesota.
Not very often, no.
Yeah.
And remember how we were talking about enthalpy control?
Yeah.
It needs those accurate humidity readings.
Right.
So imagine what happens when the system's trying to make decisions
Right.
based on these totally bogus measurements.
Right. It's like trying to bake a cake with the wrong ingredients.
Yeah, exactly.
You're just not going to get.
You're going to get a mess.
You're not going to get what you want.
Right.
Yeah.
And in this case, the cake is your building's energy efficiency.
Right.
And those bad readings were causing some pretty big problems.
Like what?
Well, for starters, the presentation found that the district's building automation system,
Okay.
the BAS,
Right.
which gets those sensor readings, wasn't updating consistently.
Okay.
And this was a real problem in that sweet spot temperature range of 60 to 70 degrees.
Okay.
Fahrenheit, when economizers are most likely to be used.
So you've got this critical temperature range.
Right.
But the system is working with old or bad information.
Right. Or both.
Right.
It's like trying to drive your car with a delayed GPS signal.
Yeah.
It's telling you where you were 5 minutes ago,
Right.
not where you are now.
So no wonder things were going haywire.
Yeah, it gets worse. They compared the BAS data to the actual weather data from Anoka
Yeah.
during those same times. And guess what?
What?
While the real weather data was updating all the time,
Yeah.
the BAS readings were way behind,
Wow.
sometimes by a lot.
Okay, so now we've got some hard proof that something's up with the data.
Right.
But what did this actually mean for the economizers themselves?
Right.
Did it actually waste energy?
Well, that's the million-dollar question, isn't it?
It is, yeah.
And the short answer is yes.
Okay.
But it depended.
Okay.
Sometimes the BAS enthalpy values were higher than the actual enthalpy in Anoka,
Oh, okay.
which meant that the economizers weren't opening as often as they should have.
So they're missing out on those energy-saving opportunities.
Exactly.
Yeah.
Those chances to use that free, cool air. But here's where it gets really crazy.
Okay.
In other cases, the BAS enthalpy was actually lower than the actual enthalpy,
Really?
which meant
Right.
that the economizers were opening more often than they needed to.
Hold on, so now they're overusing the economizers?
Yeah.
How is that even possible?
Well, remember those wacky humidity readings?
Yeah.
Sometimes those errors made the system think it was drier outside than it really was.
Right.
And that made the economizers open up and suck in all that muggy air.
Oh, so not only are they missing out on using them effectively, they're also using them when they shouldn't be.
Sometimes.
Yeah.
Talk about a double whammy.
Yeah, talk about a lose-lose situation.
Right.
And it gets worse.
Okay.
Yeah, they actually point to this one example, August 5th, 2024.
Okay.
A day when it was raining cats and dogs in Anoka.
And someone decided to compare the public weather data,
Right.
which showed 100% humidity to the BAS data.
And what the BAS said?
0.2% humidity.
Oh, my God.
Like it was on another planet.
Wow, that is a huge difference.
Yeah, it was crazy.
But did that actually affect how the economizers were working?
Oh, absolutely.
Really?
That one bad reading was being sent to every building in the whole district.
Wow.
All 377 air handlers with economizers.
Oh, my God.
They even took screenshots of every single economizer that morning.
Wow.
And get this, 212 of them.
Really?
That's 56%.
Wow.
Had their outside air dampers wide open.
Oh, so they're just sucking in all this super humid air,
Yeah.
making it more humid inside,
They're basically humidifying the buildings.
and probably making the AC work even harder to dry it back out.
Oh, yeah, they're fighting each other.
That is not good.
Not good at all.
Wow.
And as if that wasn't bad enough,
Yeah.
there was another 150 air handlers,
Okay.
about 44%,
Okay.
that weren't using their economizers at all,
Real.
even though the outside air temperature was a very pleasant 64.7 degrees.
It's like some of them were stuck on,
Right.
and some of them were stuck off, no
Exactly.
matter what.
It's like they weren't even paying attention to the weather.
Yeah, great.
It really shows you how complicated these systems are
Right.
and how even little mistakes can turn into big problems.
Yeah, for sure. So you've talked about those big swings, using them too much, not using them enough.
Right.
But this presentation also talks about these consistent differences
Yep.
between what the BAS was saying and what was actually happening outside,
Right.
like all the time.
Well,
What was up with that?
So they dug a little deeper, and they found that the BAS temperatures were always higher
Okay.
than the actual weather in Anoka
Okay.
by an average of 6.41 degrees.
Consistently higher.
Consistently.
Wow.
And the humidity readings were always lower by about 12.2%.
That's a big difference.
Huge.
Wow.
And even though those numbers seem small,
Yeah.
they have big consequences.
Okay.
So those high temperature readings, they were making the economizers close too early,
Okay.
missing out on those perfect cooling opportunities.
Right.
And then the low humidity readings,
Yeah. We've talked about that.
you've seen what those can do.
Yeah.
You end up pulling in all that sticky air.
So it all goes back to the sensors.
The sensors are key.
Yeah. If they're not right, nothing's going to be right.
They're the foundation of the whole thing.
Yeah.
And this is where things get interesting,
Okay.
because the presentation makes you think twice about the traditional wisdom
Yeah.
on economizer control.
Okay.
We always hear that enthalpy control is the best.
Most efficient.
Right. But this case study, along with some newer research, suggests that it might not be so foolproof.
Really?
Turns out that relative humidity sensors, even the really good ones, are kind of unreliable.
I had no idea.
Yeah. There's actually a study from the Iowa Energy Center.
Okay.
They found a lot of variation and just plain weird readings from humidity sensors.
Wow. So even though enthalpy control sounds good on paper,
Sounds great.
it might not actually work out that way. It's a gamble.
Especially if your sensors aren't accurate.
Exactly.
Yeah.
And that's why some experts are saying that maybe we should just stick with simple dry bulb temperature control,
Really?
at least for now.
Interesting.
It might not be perfect,
Yeah.
but it gets rid of one big source of errors.
So where do we go from here?
Right.
Are economizers just one of those things that are good in theory but don't actually work?
Well, hold on a second.
Okay.
This presentation isn't just about finding problems.
Okay.
It's also about finding solutions.
Okay, good.
And it all starts with getting a better understanding of what's really going on.
Okay.
Instead of just relying on the BAS data, which we know can be iffy,
Right.
we need a way to double-check those important sensors.
Okay.
Temperature, humidity, the whole 9 yards.
So more data. Not just more data.
Yeah.
Better data.
Okay, how do we get that?
So the presentation talks about these things called Yo-Link sensors.
Yo-Link sensors.
Ever heard of them?
I don't think so.
So they're basically
Okay.
low-cost wireless sensors
Okay.
You can easily install them wherever you need them.
Okay.
They run on batteries that last for ages.
Okay.
They're factory calibrated, so you know they're accurate.
Okay.
And they send data wirelessly to a central hub.
So instead of trying to figure out what the BAS is trying to tell us,
Exactly.
we can get real-time information
Straight from the source.
from these sensors.
Exactly.
Yeah, okay.
So you can see immediately if the temperatures and humidity that the BAS is reporting
Yeah.
actually match up with reality.
It's like giving your building a checkup.
Exactly.
Date it.
And the cool thing about these sensors
Yeah.
is that they're super versatile.
Okay.
You could put them on the air handlers themselves
Okay.
in classrooms,
Okay.
even inside the ductwork.
So we can get really granular.
As granular as you want.
I love it.
You get this really detailed view of what's going on in your building.
And that is how we can find those hidden places where we're wasting energy.
Exactly. You're shining a light on those inefficiencies.
Love it.
And here's the best part.
Okay.
What if we took all that sensor data
Yeah.
and fed it into a
Yeah.
large language model?
Like ChatGPT.
Exactly. It's not about ripping out your whole system and starting over.
Right.
It's about making it smarter,
Right.
getting a clearer picture of what's going on.
It's like upgrading from a paper map
Exactly.
to a GPS that tells you where the traffic is.
There you go.
In real time.
And imagine having this across all your buildings.
Yeah.
All those sensors feeding into one place.
Right.
And that LLM is looking at it all.
Finding those problems before they even happen.
Exactly. We can stop reacting and start preventing.
Yeah.
That's where the real savings are.
Yeah, and it's not just about saving money.
Pretty
It's
much.
about the environment, too.
Absolutely. Every kilowatt hour counts
Exactly.
for a greener future.
It's a win-win, really.
It really is.
Lower costs, more comfortable buildings, and we're helping the planet.
What more could you ask for?
Exactly. And it all starts with asking questions.
Exactly.
Like Michael R. Lavelle did.
He really dug into the data,
Challenging assumptions.
and he found some really interesting stuff
He did.
about a system that a lot of people just take for granted.
Yeah, they just assume it's working.
Yeah.
But it might not be.
It's a good reminder that we can always be doing better.
Exactly.
There's always room for improvement.
And sometimes the biggest changes come from questioning how we've always done things.
Exactly.
So if you're out there listening,
Yeah.
and you've got a building
Or even just a room.
with an economizer, don't assume anything.
Yeah.
Ask questions, get the data.
You might be surprised.
You might find some hidden savings,
Exactly.
help the environment.
It all starts with a deep dive.
And that's what we're here for.
That's right.
This has been the Dupe Dive.
Until next time.
We'll see you on the next one.